Industrial waste refers to the leftover materials generated by factories and manufacturing processes. This waste material can be harmful to the environment and human health if not properly managed and disposed of. Industrializations move parallel with growing waste production, such as industrial wastewater. This wastewater should be treated before it is released into the environment due to the following reasons. First, environmental protections. Second, human health protections. Third, water resource conservations. However, absorption is regarded as the most promising treatment method because of its low cost, simple operation procedure, high efficiency, and environmental friendliness. Green chemistry, also known as sustainable chemistry, is an approach that aims to develop chemical products and processes that are sustainable.
I will continue by introducing sodium alginates. Alginates are refined from brown seaweeds. Many of the class brown seaweeds are harvested to be processed and converted into sodium alginates. Brown seaweeds are ranged in size and different species possess vary in their chemical structure, resulting in different physical properties of alginates. The linear anionic polysaccharide consists of two residues, namely beta-demonuronic acid M block and alpha-L-gluuronic acid G block. These blocks arrange in repeating M block, repeating G blocks, and mix of M and G blocks.
Our project aims to provide environmentally sustainable method of waste management. And to get this done, we designed a sober material in bead forms that has high adsorption capacity and efficiency for waste management.
Alright, since we're talking in the context of green chemistry, there are several studies that have found that the absorption method is considered as the most economical and effective. Thus, as for our innovation in addressing the issue of wastewater treatment, we have decided to use beads, which are also known as microspheres due to their various properties that portray a great performance as a highly efficient adsorbent. So, these beads have been proven that they can provide a high surface area and low particle size. Apart from that, these microspheres or beads are also can exhibit a prolonged residence time. Besides, scientists work with the beads by doping a various heteroatoms and function units to them as they have a strong scalability. And last but not least, reusability as an important performance index of microsphere adsorbents. It has been highlighted by several studies that some excellent microspheres or beads can continue to maintain high absorption capacities and removal rates after 3 to 5 cycles under experimental conditions.
Now I'm going to focus on adsorption of sodium alginate beads. Water is essential for life, but unfortunately it's not always pure due to contaminants and impurities. To overcome this issue, raw water will undergo the process called filtration. Water passes through a physical barriers removing contaminants and suspended particles. After that, water go to the next section called adsorbent column, which chemical adsorption occurs. During adsorption, sodium alginate beads is introduced to contaminated water. They go to work attracting and capturing impurities like a magnet to form monolayer. This adsorption process becomes highly efficient in targeting heavy metal due to its large surface area. The spent beads, which the adsorbent material that has already captured and retained impurities, can undergo regeneration to use back in the process.
Next, moving on to the advantages of using sodium alginate in waste management for water treatment. First, sodium alginate can be broken down by microorganisms, making it ecologically friendly for waste management of water contamination. Next, sodium alginate has the ability to bind with various contaminants in water and absorb with it to effectively reduce the presence in the polluted water. The last part is the advantages of using sodium alginate in beads form. So first, it improves solubility. The next one, sodium alginate beads are easy to handle. They can be easily dispersed in liquids or even mixed with other ingredients without altering the overall product characteristics. Next, sodium alginate beads can be customized in size and also shape to control release and suit various product formats. And the last one, it is cost-effective production. Sodium alginate beads can be produced economically on a large scale using cost-effective techniques like ionic gelation due to the availability and affordability of sodium alginate as a raw material.
These two articles have proven the success of using sodium alginate beads in water treatment. In general, the first article studies the removal of organic micropollutants, whereas the other article discusses about the removal of metal ion from water sources. Both studies shows a successful adsorption properties toward the targeted pollutants. The beads sodium alginate also demonstrates good recyclability as the removal of efficiency retains higher than about 50% after use for 4 cycles. Therefore, this type of porous beads with large amount of active binding sites are considered versatile, efficient, and easy renewable adsorbent for water treatment.